Now, will that fiber start getting tested? Are there challenges for you in the fiber business to further advance the technology to handle all this?
I think that when you think about communications in general, right, there are challenges right now. If you start from the core of the network in data centers, for instance, energy is the biggest challenge right now, right? Energy and power consumption inside data center is a big deal. So the entire industry has to work on that. So it's not only about the companies that are making servers or switches, but you're going to see there a lot of effort going to integration between photonics and electronics. That intercorrelation there needs to be more lean and provide, you need less picojoules of energy per bit, basically. You have to reduce that. You're going to reduce that miniaturizing components, leveraging some new technology that we are working to when you think about nanotechnology, meta surfaces. So there are some new devices that will come out of that, because then you reduce the size, you integrate photonics and electronics, and that's how you reduce the energy per bit to transmit. If you go more into the optical side, I think that photon management, what we call, which is a combination of guiding and coupling. How can I get the photons in and out the fiber, and how can I make sure that they stay there with the minimal possible loss? This is going to be critical when you get into quantum communication and other things like that, but also as you try to connect those new devices, those more smaller and more energy efficient devices to the network. So there is a lot of, it's interesting because it's a moment where we are seeing a lot of opportunities for innovation on products, on devices, but also a lot of fundamental research going on, right? We are dealing with energy limitations now. We are dealing with things that are extremely fundamental. And again, that's a piece that I feel great to be working for a company like Corning, because fundamental research is going to be essential for that. Not all companies have the guts to actually invest in fundamental research, and we do. And I think that is going to come and help us significantly in this new phase that we're going to face.
And these research efforts are helping us deliver products right now. So a few weeks ago, we introduced a new optical fiber that is designed for the final connection to a home or to a building. The idea is that we not only make it more bend tolerant, but we also make it more compatible with the existing fibers in the network, how we get photons on and off that fiber, so you don't have to do complicated splicing. That takes labor out of the installation, makes it cheaper for our customers, but there are a lot of opportunities along these lines, and you'll see more products for us in the not so distant future to do this.
Actually, this it's a great example. Optical density networks translates into many different things, right? More fiber connecting 5G antennas, etc. But also go to the core in terms of more density inside cables. Today there is a challenge between campus and data centers where you have a limited number of ducts, and you have to put more fibers there. So we actually need to put more fibers inside the cables. We're going to, several thousand fibers inside a single cable for those connectivities. And the fiber that was just launched that Jeff mentioned allows you to do that. You can put more fibers inside the same cable and make the cable still bendable and so forth. So that optical density is driving some of those new innovations too.
Just to amplify on Claudio's and Jeff's points, and as a researcher looking at the long term and living in Silicon Valley, it's one of the most important things to realize is the science and technology community in Corning. That's where research and development happens. And add to that the fact that the senior management has the patience to wait for the research to see the results. Without that, we'll not have the amazing innovation engine that we have here. So just to amplify this point, it takes some patience, but the dividends that they pay in the future is just amazing.
Okay, that's great.
And I think, Corning, thinking back to my time on the sell side when I covered Corning, I think Corning has always had that patience. I think that what's different about it now is that we've focused around a set of capabilities and markets where we can constantly reuse and reapply. So Claudio was talking about using flat glass as an interconnect to take photons closer to the chips in a high-performance server or networking device. The starting point is our flat glass that we innovated around the process first for display, where we're using fusion to make a glass that's chemically optimized, that has incredibly precise surfaces without polishing. Then we took the optics of that to work on things like the backlight for displays. And when we're doing that, we're also learning to write structures and waveguides in the flat glass itself. That work helps us in display. The work in display helps us with a new set of opportunities in optical communications. The work on ultra-low loss fiber sets us up to do quantum communications, and people are setting records on it. So it lets us exhibit our patience, which is the heritage of Corning, that things take a long time to play out, but develop intellectual property and capabilities that can help us in the here and now. And I think that makes us much more capital efficient over time.
And they take this thin glass, put some accurate holes in it, and use it, as you mentioned, as an interposer for packaging of very high performance IC chips. It's just amazing that some had the vision to find that application. So hopefully in the future that will find use.